This video is about finding the rule of an exponential function when you are given the coordinates of at least 3 consecutive points. In this situation, constructing a table of values helps a lot. Before we start, remember that the rule of an exponential function in standard form is f of x equals a times c to the power of b times x minus h plus k. We can simplify the standard form thanks to the laws of exponents. We then get a simpler form of the standard rule, which is f of x equals a times c to the power of x plus k. To find the rule of an exponential function, we must therefore determine the value of parameters a, c, and k. Let's do an example. We are looking for the rule of the exponential function that passes through the points 1, 6, 2, 0, and 3, negative 12. Let's start by putting these points in a table of values. We notice that the x values are consecutive, meaning they come one after the other. The points 1, 6, 2, 0, and 3, negative 12 are therefore called consecutive points. When the coordinates of 3 or more consecutive points are known, it is possible to find the value of parameter c by determining the multiplying factor. We must therefore look at the change in y. To go from the first to the second point, the change in y is minus 6, while to go from the second to the third, it is minus 12. To find the multiplying factor, we need to ask, what must I multiply negative 6 by to get negative 12? The answer is 2. So the multiplying factor is 2, and this is the value of parameter c. We can enter this value in the rule. Next, we have to find the values of parameters a and k. Since we do not know the equation of the asymptote, we cannot use it to determine k. We can't directly find parameter a either. Since we have 2 unknowns, we can create a system of equations using the coordinates of any 2 points. Let's start with the point 1, 6. By replacing the coordinates of this point in the rule, we get 6 equals a times 2 to the power of 1 plus k. For the second equation, if we take 2, 0, we get 0 equals a times 2 to the power of 2 plus k. Now we have to solve this system of equations. We will use the substitution method because it's the most efficient in this case. However, you could have used the elimination or comparison methods too. We isolate a variable in one of the 2 equations. Let's isolate k in the second equation. 2 exponent 2 is 4, which gives the equation of 0 equals 4a plus k. We subtract 4a from both sides of the equation and we get negative 4a equals k. We replace k in the first equation with minus 4a. Simplifying the equation, we have 6 equals 2a minus 4a. Since we end up with the 2 like terms, we can subtract them and we get 6 equals negative 2a. To isolate a, we just have to divide by negative 2. We find that negative 3 equals a. We can therefore replace a by negative 3 in the rule. Only parameter k is left to find. We can use one of the 2 previously found equations to do this. Let's take the second one since k is already isolated. We replace a by negative 3. Negative 4 times negative 3 equals k, which is 12. We can replace k with 12 in the rule. We can also conclude that the horizontal asymptote passes through y equals 12. It's possible to check if the sign of parameter a corresponds to the graph provided. We can see that the curve is below the asymptote, so the a value must be negative. This is what we found. We can also use the graph to check if the k value makes sense. K is 12, so the asymptote is at y equals 12. This seems to be the case since it's above the point that has the 6 as its y-coordinate. So the rule for the exponential function is f of x equals negative 3 times 2 to the power of x plus 12. I hope this video about finding the rule of an exponential function from 3 consecutive points helped you to better understand. If you want to know more about how to find the rule when given the y-intercept and a point or given 2 points in the asymptote, we have videos for that. Check them out.